focus task for this unit is to recreate this wine glass using only the functions that we have learned so far. So in order to do that, we need to start looking at what kind of functions make up this wine glass. So if we start at the top, right here, we can see we have one horizontal ellipse. So one horizontal ellipse. As we move down, right here, we can see this kind of looks like half of a vertical ellipse. So let's put that down as one vertical ellipse. If we keep going on down here to the stem, we see we have two vertical lines as well as a little horizontal line. So that's two vertical lines, one horizontal line, and here at the base we can see we have another ellipse. So we have another one horizontal ellipse. So now that we've established what kind of shapes we have, now we need to start looking for a couple of dimensions. The best way to do that is to start by placing an origin somewhere on your glass. There's a couple of different places what we can choose for our origin. The first one might be right here. So that's one of the spots that we might choose. Another place might be here at the bottom of the glass, or right here at the end of them. So those are three convenient locations that you can choose. The one that I've decided to use is this one right here. So now that I've decided on an origin, now I can draw in my axes. So this one here is going to be my horizontal axis, or my x-axis. And this one here is my vertical, or my y-axis. Our next step is to start assigning a couple of different dimensions that we're going to use when we create these functions. So let's start off with the horizontal ellipse. So let's make our horizontal distance here, let's make that 5. So again, you can choose whichever number you'd like to use, but in this case, I'm using 5 just for convenience sake. For my vertical distance, I'm going to choose a value of 2. So this distance here is 2. Let's now look at our vertical ellipse. If I want to make my vertical ellipse, let's say this distance is 8. Let's make that distance there. And if we look at our vertical lines, let's make that vertical distance, let's let that be 8 as well. And let's make this distance here, so the width of our stem, let's make that a unit of 1. The last ellipse is a little bit more tricky because we don't want any overlap right here. So I'm going to save the dimensions for that one until the very end.
So let us consider the restrictions and equations for these functions. The general form of any ellipse is given by the equation x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Here, our h and k represent the center of our ellipse, the a represents the horizontal distance, and the b represents the vertical distance. So let's consider this horizontal ellipse. We're taking the full ellipse here, so we can just write the equation for this ellipse. Our center is placed at 0, 0, so our h and k are 0, 0. The horizontal distance here is 5, and the vertical distance here is 2. Therefore, our equation for this horizontal ellipse is x squared over 25 plus y squared over 4 is equal to 1. Next, let us consider this vertical ellipse. Since we're only taking half of the vertical ellipse, and we're taking the half that's below the y-axis, below the x-axis, let us just make the restriction that y is less than or equal to 0. Again, our center for this vertical ellipse is 0, 0. The horizontal distance is 5, the vertical distance is 8. Therefore, the equation of this ellipse is x squared over 25 plus y squared over 64 is equal to 1, but we're restricting this for y strictly less than or equal to 0. Next, let us consider these two vertical lines. We know that this distance here is 1 unit, so the distance from the axis to the vertical line is 0.5. So here, this equation here would be x is equal to minus 0.5, and this vertical equation would be x is equal to positive 0.5. Now, we only want these equations to hold true from this y value to this y value. We know that this y value is minus 8, and then adding on another 8 to that would be minus 16. So we're going to restrict these two equations for y between minus 8 and minus 16. So let's forget about this little portion right here for a minute and consider this ellipse and put some more parameters on it. Now I just want to put some numbers on this ellipse. From the center, I want to define that this value here is 5 units long, and this value is, say, 2 units long. Okay? I need to also consider my center. My center here is at x equals 0, and y goes all the way down to minus 16. Therefore, the equation of my ellipse here is given by x minus 0 squared over 25 plus y minus a minus 16 squared over 4 is equal to 1. Now, to define the restrictions on this ellipse, we have to consider this in the following cases. Let us consider what happens when y is strictly less than minus 16. So for y strictly less than minus 16, what we want our program, or what we want our function to look like, is just this ellipse. So it's just going to be this equation of the ellipse I have written out above. Now let us consider what happens when x, or when y, is bigger than minus 16. So for y bigger or equal to minus 16, we also have to place further restrictions on here because we don't want to draw the ellipse between these regions. So for y less than or equal to y greater than or equal to minus 16, and if our x is either less than minus 0.5 or greater than minus 0.5, x is greater than or equal to positive 0.5, we want to again draw our ellipse. Now the only section we have left to consider is this little portion right here. So for y bigger than or equal to minus 16, and if x is now between minus 0.5 and 0.5, we don't want to draw the ellipse. We want to instead draw this little horizontal line here, which is given by the equation y equals negative 16. So now, if we input these values into a computer software program or a graphing calculator, we can produce this ellipse as shown to our right.